Good day everyone. In this video, we will talk about IR spectroscopy. Let's start with this introduction video and watch out for the following basic concepts. First, what is IR spectroscopy? What is a wave number? What an IR spectrum looks like? And what is the fingerprint region in an IR spectrum?
Infrared spectroscopy is a technique used to analyze the bond types and functional groups present in organic molecules. Covalent bonds can absorb specific amounts of energy to vibrate in certain ways, and different bond types absorb different amounts of energy to do this. For most organic molecules, the bonds in them can be made to vibrate using energy found from the infrared region of the electromagnetic spectrum. This means if a specific wave of IR radiation is shone at a sample, the corresponding bond type in the sample can start to vibrate by absorbing the energy from the wave. By bombarding a sample with a complete range of IR waves, the wavelengths of IR that get absorbed by the sample can be analyzed and the types of bond in the molecule found. Wavelengths are used to distinguish between different IR waves. However, wavelengths are very small, meaning wave numbers are used instead, to make things easier. A wave number is just 1 divided by wavelength, with units of centimeter to the -1. The bigger the wave number, the smaller the wavelength, and higher the energy of the wave. Tables are produced that show the range of possible wave numbers a particular bond type is likely to absorb. The same bond type in different molecules will absorb slightly different wave numbers, which is why a range of values is always given in such tables. In infrared spectroscopy, spectra are produced that show the waves that pass through a sample. This is called transmittance. Any waves or wave numbers that weren't transmitted must have been absorbed by bonds in the sample. These wave numbers absorbed can be compared to a data table and the corresponding bond types can be determined. Below wave numbers of 1500, the absorptions of IR waves are associated with vibrations and motion of whole molecules, meaning they are very complicated to analyze. The combination of all absorbances and the shape of this region is, however, unique to a particular molecule, meaning it is referred to as the fingerprint region. Due to its complexity, it isn't analysed in detail at this level and is instead just used to quickly identify given substances.
Here are some important things that I hope you got from the introduction. IR spectroscopy is a type of spectroscopy which we all know is simply a technique that uses light and the light absorbance properties of substances for analysis. From the name itself, it uses IR or infrared light. The wavelengths are longer than the red light in the visible spectrum, thus it has a lower energy. Now, which part of the molecule interacts with infrared radiation? Well, IR actually causes molecules to vibrate, or in other words, cause bonds to bend and stretch, causing tiny displacements within atoms of a molecule. Of course, IR energy is not strong enough to break these bonds. Specific bonds that absorb IR radiation significantly are those compounds with CH bonds, C double bond O bonds, OH bonds, and CN bonds. Basically, the functional groups in organic molecules. And generally, the higher the electronegativity difference, the higher the absorbance, and the stronger the signal. The IR spectrum has wave numbers in the x-axis and transmittance in the y-axis. Don't confuse this with the UV-Vis spectrum because the IR spectrum has the baseline at the top and the peaks are inverted by convention. So overall, IR spectroscopy is used in qualitative analysis, specifically in determining functional groups present in a sample. Now, because this is just an introduction to IR spectroscopy, let's not overcomplicate things and focus on the basics. First, we will be ignoring the fingerprint region and simply focus on the region above the wave number 1500. Then, we will follow the checklist I will show here. Using this, we will spot very distinct peaks that correspond to different functional groups. These are the peaks that usually stand out in an IR spectrum and are hard to miss. We will discuss these 5 things in the checklist in order in the next slides. Note that peaks at 2850 to 3000 are not so special because they are almost always there, and this is because of the CH bonds that are ubiquitous in organic molecules. First is the broad peak at the 2500 to 3400 range. This is due to the OH bond. Let's take, for example, this IR spectrum over here. This is the IR spectrum of an alcohol, specifically hexanol. First, we have to ignore the fingerprint region, and we also have to ignore the CH peaks as mentioned. We are given a list of numbers over here. So the first column is for the wave numbers and the second column is for transmittance. The lower the transmittance, the higher the absorbance, thus the stronger the signal and the more obvious the peak. Now going back to our checklist, we want to ask first, is there a broad peak? So usually it's not pointed, it looks more like a curve. Obviously, we are talking about this peak over here. So when you see a broad peak like this, it suggests that the OH group is present. Next in our checklist is if there are peaks at 3300 to 3500. This is due to the NH bond. Let's take a look at a different IR spectrum this time. So this is an amine, specifically cyclohexylmethylamine. Again, we will ignore the fingerprint region and the CH peaks. So what you are going to see are the peaks over here. So those peaks are due to the NH bond from the amine functional group. Next thing to check is if there is a really strong peak at 1700 or around that area. This is due to the carbonyl group or the C double bond O. For the IR spectrum of cyclobutanone, for example, you will be able to see the highest absorbance at 1783. Fourth in our list is the small peaks at around 1700 to 1900. Many compounds with aromatic rings have these small peaks with nearly the same height. These are also called overtones or benzene fingers. Looking at our sample IR spectrum, which belongs to toluene, you can see these overtones in this area right here. Now that you've seen the 4 distinct characteristics in an IR spectrum, what if there is nothing quote-unquote special in the IR spectrum? Well, in that case, most likely it is a hydrocarbon only. For alkanes, all we get are peaks in this 2850 to 3000 region. For example, this is the IR spectrum of cyclooctane. Next, for alkenes, you can look at the 3020 to 3100 region. Okay. Plus, it also has a peak at around 1600. So, as seen in the IR spectrum of 2-methyl-1-butene. Lastly, for alkynes, there is a distinct peak at 2100 to 2250. And if the alkyne is at the terminal position, it will have a strong peak at around 3300. This is shown in the IR spectrum of 3,3-dimethyl-1-butene. Now let's just go back to our checklist, and I recommend that you take some time to review the important points. Hopefully, you will find it easy to determine which functional groups are present in a sample just by looking at certain peaks. Take note, however, that this is an oversimplified way of looking at IR spectra. There is so much more data that we can get from here, which leads me to the next slide. This slide shows a longer list of the types of bonds and their corresponding wave numbers. You might want to pause the video to take a longer look at the table and probably take a screenshot of it for your reference later on. Also, you might want to watch this video for some practice in matching the IR spectra to the correct functional groups. The following video is approximately 12 minutes long.
We're going to match the functional group to its IR spectrum, plus we're also going to circle the area that represents that functional group.
Okay, I see what you're saying.
Let's start with this one.
Okay.
So
This one.
now you would be given something here where it actually tells you the different values.
So nice.
I'm not just going to throw you into the water, and especially on your exam, you will actually be given something like
That
this.
is true. That is true.
Yeah.
Okay, so I know we're looking at like the 3,000 range. So it would be less than that. Probably one of these. Yeah, I'd say one of these three. Because it's a little bit less than 3,000. So I'd go with this one. CHSP3, because it like ranges from like 2,850.
That's right.
Yeah?
That is right, but that's not our functional group.
Oh, I see what you're saying. Oh, okay.
That's just like an extra R group that's attached.
Oh, okay.
So you'll notice that, look, all of these pretty much have something within that region, right? Or this one, not so much. But within that region, there's like 3,000 or something like that. I know that's going to be an sp3 hybridized carbon or
That's
atom.
what you're saying. Okay.
And that, again, that's just typically like a carbon chain.
Oh, okay.
But that doesn't help us.
Yeah, that's true.
We want to figure out what functional group there is.
Oh.
So I would say what we want to do, we still want to focus on the functional group region, which was greater than 1,400. So I know, okay, that's going to be
More than that.
to the left for each one. So, okay, is there anything else? We've identified what that was. Doesn't help us. Is there anything within that functional group region that could tell us what the actual functional group is?
Oh.
So I'm just looking at that cutoff.
Okay, that makes more sense. Okay. I'm leaning towards the ketone.
Okay.
Just because it's in the range.
Go ahead and circle the area that you're talking about, the peak that you're talking about.
This little guy
Good.
on the left side
Okay.
of the 1,400.
And you said a ketone.
Yes.
Label it.
Really? Okay. Is it right?
Yes, it is.
Okay.
It's not a trick, but yes, it is. So this is going to be a better guide here to be able to understand pretty much the different carbonyl groups, where for all of them, you'll notice the carbonyl portion of it, that's going to be within like 1700s.
Oh.
And I know that this doesn't actually give you an exact number, but it's within that range, right? 1700 is probably roughly there.
Yeah. Okay.
So that does tell me, okay, that is that peak that it shows me. Plus for a ketone, there's only one peak. There's nothing else. There's no other peaks. Like an aldehyde is going to have two different signals at these
I
peaks.
see what you mean.
You know, the carboxylic acid has a distinct feature as
it's
well.
weird.
You know, there's another peak that's going to tell us the OH. Same with an acid chloride, an ester, all the other ones. But the ketone only has that one carbonyl group.
Okay.
We're not accounting for, and actually this makes sense for the R groups, that this had to be the R group, one of these R groups, because that's within that range of sp3 hybridized.
That totally does make sense.
Good.
Oh,
Good
okay.
so
That's
far.
helping me already. Okay, that makes sense.
Let's try this one.
We're looking at the range, and we're not really looking at anything on this side because this is like on the fingerprint side, right?
Correct.
So pretty much everything from this side. This one's interesting. Okay.
What's the little peak that you're thinking of?
This guy right here.
Circle it. And then an amine is roughly...
We're looking at like this range, which is pretty high.
It is.
And it would fall under that.
It would,
so,
yes. We have 3,000 to 3,500. Yes, that's correct. So I would say an amine. Now we have two options, a primary or a secondary. Do you remember the difference?
The amount of peaks.
Good.
Because I want to say this one's also an amine, and like if I were to compare them, I would say this is primary because there's one, and this one's secondary because there's two, but I don't remember.
Let's circle this one as well because you're right. You're right that these two are amines. And it's exactly what you're talking about. It is with the peaks. But I want you to think back, and if we can look at this.
Absolutely.
This is what type of amine?
That's just the primary amine, right? I can't remember. We look at the R groups.
We look at the R groups.
Secondary.
That's secondary,
Okay.
right. So secondary. Now notice this is highlighted. Just the N connected to the H, or the nitrogen connected to the hydrogen, that tells me that's within this range. There's only one hydrogen there, so there's only going to be one peak. Okay. When there are two hydrogens, which is a primary amine, there's going to be two peaks.
Oh, I see.
So for every nitrogen bonded to a hydrogen, we see a peak within that area.
Oh, okay. So this one would be the primary then, because it's bonded to
Yes.
the two.
Here. So yeah, primary, really two hydrogens, that's what we're looking at. It's the nitrogen connected to a hydrogen. That's why there's two peaks. If there's just one hydrogen, the secondary amine,
Okay, that makes
then
sense.
there's just one peak.
Okay.
So let's
That's
label
gonna make
each.
sense.
Now, the first thing you want to do with these types of questions is look at the functional group region, which we said was greater than 1400.
Yes.
Now, you start to kind of look at what could it possibly be? Like, is there a specific peak feature, and it's not just confusing you and telling you, oh, that's like sp3 hybridized.
Right.
Let's not get tricked by that.
Weird.
So whenever we see something that is within its own range, we can then figure out, okay, what type is that?
That makes sense.
What you saw was you're like, it's some sort of amine. Okay, what's the trick to that? Well, secondary, one peak, primary, two peaks. Okay, move on.
That helps. Okay, I like that. Okay.
After this video, head over to community.com and join Community for free. Go ahead and try this one.
I know this one is, because I'm used to like seeing the ones around the 3,000 ones because those are like the most distinguishable peaks.
Yes.
So I want to say that has something to do with an alcohol because it is in that range. But then do I have to look at this guy too because that's like pretty strong?
So what was this again? What is that range between?
It's like 3,000. That's pretty close. So,
Are we getting fooled?
oh, maybe.
The 3,000 range? So let's go back to the ketone. 3,000 range. What was this?
Oh, I see. Yes, you're right. Oh, yeah, we are. It literally is the same. Oh, it's just
That
telling me
was
it's sp3.
sp3
Okay,
hybridized.
I am totally getting
That's
good.
just an R group.
Oh, okay.
Now I can again look at the,
That strong one.
yep.
And that one is a little bit more than 1,500. So, and I have my little options here.
You do. I'm gonna add another option.
Oh, is it another ketone?
It is another ketone.
Oh.
Let's circle it again.
And is
the
it because
place.
it's one peak?
Just one peak.
Oh, I see.
Yep, it was just the fact that I just have that one peak. There's nothing else attached. There's no OH, so I can't state that that's within that area, right, which would have been between here. So it would have been here. There's nothing there. The only main thing that I look at, this really strong peak. And by strong, I mean it's like long.
Long, yeah.
Good. So let's label that and state, okay, it's another ketone.
Okay. And we just did that. That's so silly.
We did.
Oh my gosh. Okay. Now that makes sense.
What about this one?
Okay, I want to say this one's carboxylic acid.
Okay, why?
Because it's broad.
Okay, good.
And I remember when I learned about this, that, because I mean, alcohol can also be broad too.
Good.
But it has like this weird, like,
Little
like,
peak thing.
fade off,
Yes,
You know
yes.
what I mean?
Circle the little area that you're talking about. I would actually say it's here. So we want this little groove. Like this is the broad portion.
Oh.
And by broad, it's really saying like, okay, it's like this was narrow.
Yes.
Right? Broad is it's kind of chunky, it has that kind of shape to it.
Okay.
Concavity, So this is the little area that we're looking at. What is within this region? Because keep going with your thought. You thought maybe it's between an carboxylic acid
Right.
or an alcohol.
I was thinking like around this, that would be in the range. But then
What other peak is you think would be important? That's
This guy?
good. Let's circle it. What's that probably telling us that there is?
It's a single peak again.
Uh-huh.
And it's around like the 1700
Good.
mark. So is it another ketone?
So
Or-
it's within that carbonyl range, right?
Uh-huh.
Whenever we see a strong peak, that's probably roughly 1700. I know there's some sort of carbonyl group. So then I look at, okay, has to be at least something on here.
Mm-hmm.
If there is a carbonyl group, then I know that it's actually not going to be a ketone in this case because there's an additional peak that isn't an sp3 hybridized.
Oh, I see what you're saying. Okay.
You know, there's no R group that it's showing me. So because of that, I know the ketone's out. Now I have to figure out, what is this? You know, what is within that range looking at the different carbonyl groups?
Would that, okay, let's see. Because it is 1700, and then we're looking at like a high, is it an amide? Well, let's see.
Wouldn't be in this case, just because it's broad. Honestly, that's the main giveaway.
Really?
So
Okay.
the main giveaway here was that it was broad. So the difference between an alcohol, carboxylic acid, is exactly what you were talking about.
Mm-hmm.
It had that sort of strained broadness here and then little peaks going off.
Mm-hmm.
That was a carboxylic acid. So what's showing here is this is the carbonyl group.
Uh-huh.
This little broadness is that OH group that we have for
Okay, I see what you're
carboxylic
saying.
acid.
Yeah.
So then that's the giveaway.
Oh,
So we know this one would have been carboxylic acid.
okay. Interesting. Okay. That's making more sense because I'd always like split it up and like look at this and then this.
Mm-hmm.
And it just didn't make sense because I wouldn't be getting
It's
I
like
get
piece by
two-
piece.
Okay, so
Yeah.
together they form one thing. And
Yes.
Then, okay, that's making way more sense.
You're really just looking at, I know this is just telling me the oxygen connected to the hydrogen. That's here. This is that carbonyl group,
okay.
carbon double bonded to oxygen.
And
that's
that's
here.
there.
And then you
Oh.
piece them together and you know, okay, carboxylic acid.
Okay, that makes so much more sense. Okay, I like that.
What about this last one?
Okay, so this little area right here,
Mm-hmm.
this peak
Yes.
is it's high. So it's like the alcohol region. It has like
Good.
an OH bond.
Let's circle it. And what's left?
And then, so alcohol?
It is. Yeah, you're right. There's no trick here. No trick. And that's exactly what we saw. We saw that this was broad.
Okay.
You know, it might not be too intense,
Mm-hmm.
you know, or strong because it's not as lower down, you know, like compared to these that we've seen.
Yes.
But it is broad. It is kind of fatter, you know,
Yeah.
as you can think of
Yeah.
it. It's not narrow. So that's really it. That's all you're looking at here because what is this?
That's just telling me that it's SP3, right?
Yes, some sort of R group.
Oh,
That's
okay.
it. Every time you see this sort of funky looking, you know, peak area for all of these, and they're all within that, I'd say
makes sense.
3,000, you know, region, then that's just telling me there's an R group.
Oh, okay.
And then that's it. The main thing I would say that could possibly trick you was the alcohol and carboxylic acid, not remembering which one was which. And then same with the amines.
Yeah, that one, secondary. Because I switched my R's and my H's, and I was like, oh, wait, we're looking at H's. And okay, yeah, that makes sense.
Yeah. Secondary, it's kind of the opposite of what you're thinking. There's only going to be one. Primary, there's only going to be two peaks.
Right, so interesting.
It's like opposite.
flipped. Okay,
Yes.
nice, I like it.
Not too bad. We're off to a good
Yeah,
start. We
that's
know
helpful.
how to identify everything now.
Oh, yeah, that makes so much more sense.
And we did not use this. That was
okay,
a trick.
I was like, were we going to? Okay, that's perfect.
And then just in case, just so you know, the difference is where, okay, if this was an alkyne, there would have been a peak within this region. So I'd say roughly 2100 to 2200. And there's nothing there, right? There's nothing nothing here. Same, it just keeps going. We would actually have like a sharper peak
Oh.
or more narrow peak that would show there. Same with an alkene.
Okay, yeah.
But no, we don't have that, so that's out.
Oh, perfect.
In conclusion, IR spectroscopy is an analysis technique that can determine the functional groups present. This technique does not exactly tell how atoms are bonded or how many atoms there are, but it can be used in identifying the possible types of compounds based on the functional groups in the spectrum. Also, this may be useful for getting structural information. However, it is limited to qualitative analysis. That's all for this video. Thank you for listening.